Hello everyone. I have prepared these notes for my students, and I thought that I should discuss with you as well. So if you like, it will be very helpful for you. Okay, so without wasting time, let's start our physics chapter as per new syllabus. The name of the chapter: Journey Inside an Atom. So you will get the handwritten notes with full explanation, as well as the solutions of all NCRT and pose and ponder also included in these notes. So without wasting time, let's start. Okay, so how it is start? Everyone know what is atom. Atom is the smallest particle of any matter. Everything is made up of matter in this world, isn't it? That you can see, touch, or feel. Okay, everything is made up of atom. So atom is the smallest particle of matter. Okay, and even our body cell made up of atom. Okay, now rediscovering the root of atomic theory. Okay, what is the atomic theory? So before 2000 years ago, okay, these three philosophers, you can say, okay, they are not scientists, because their theory, atomic theory, not based upon the scientific knowledge, scientific facts. Okay, this is only based on their thinking and imagination. Okay, so 2000 years ago, Acharya Kanad from India proposed dividing matter until it can't be divided anymore, called the smallest piece, and that is Parmanu. Okay, he named the smallest piece of matter Parmanu. Okay, if two atoms or two Parmanu consist, it is called diode. For three atoms or three Parmanu, it is called triads. Okay, now to ancient Greece philosopher, they are named Democritus and Leucippus. Okay, they also proposed individual particle called atom. It means they called this Parmanu atom. Okay, but after 2000 years, okay, 2000 years later, the John Dalton gave atomic theory, okay, that was scientifically proven, okay, or scientific atomic theory. That was the first scientific atomic theory. Okay, and he also called that matter is made up of fundamental individual particle, and he called it atom. Okay, what this theory explained? Okay, as per Dalton theory, he gave this theory in 1808, that matter made up of atom, compound formed when atom combined. Second point. Third point, chemical reaction involved rearrangement of atom. For example, how we can explain compound formed when atom combined. Okay, hydrogen plus oxygen, it will give you the water molecule. Okay, and water molecules form a compound, that is water. Water is a compound. Okay, so this is how atom combined and form compound. And also chemical reaction involved rearrangement of atom. Okay, because rearrangement is happening of hydrogen and oxygen, and in product we get H2O. So this is rearrangement. Okay, and the last point, different element have different atoms, because hydrogen atom are different, and carbon atom are different, isn't it? Okay, or I can say these are not equal. Hydrogen atom is not equal to the carbon atom, isn't it? So they both have different atoms. So you have to learn what he explained in his theory. Okay, these are the point I have written. Okay, and I told you these are the philosophers. So what they said about atom was their philosophy or imagination or their thinking. Okay, it was not scientific. I'm talking about these two. Okay, and how they the atom came into existence. The name atom came into existence. A means not, Thomas meant cannot cut, so which cannot be divided, that they called atom. Okay, and according to Dalton, the atom is like a solid. Okay, like a solid ball or football, but nothing inside. Okay, he named that thing atom. Okay, and in this chapter we will study that how the atom evolved. Okay, so Dalton called atom individual sphere, solid sphere, nothing inside. Okay, but in further in next you will learn the other scientist atomic theory as well. Okay, so let's start. Why Dalton theory was important? First, because it was scientific theory and it explained many chemical facts. Okay, and it gave clear idea of chemical reaction. Okay, isn't it? Water and oxygen, this is the chemical reaction when they are combining, and this was the foundation of scientific chemistry. That's why that was very important. Okay, and here I have mentioned postulates. means what are its characteristic of atomic theory and what are the limitations of Dalton theory. So that I have already explained, so you just read, it's very easy. Now what is limitations of Dalton theory? Okay, according to Dalton theory, atoms are not indivisible. It means you can't divide atom. Okay, but later electron, proton and neutron were discovered inside atom, isn't it? So that's why it was not correct, because atom is divisible. Atom has electron, proton and neutron. Second limitation, atom can be created and destroyed in chemical reactions. Okay, because Dalton said atom cannot be created and cannot be destroyed, but it can be created or destroyed in nuclear reactions. For example, uranium form other atom, okay, when reaction happen and a lot of energy is released. And third limitation, atom of same element are not always identical. Okay, he said that hydrogen, all atoms are identical, hydrogen atom or carbon atom, but hydrogen and carbon also exist in form of their isotopes. Okay, that we will study later in this chapter. So atom of the same element are not always identical. Okay, they also have their twins in nature. And the fourth one, atoms of different element may have same mass. Okay, you can see these are different element, they can have same mass. It means he cannot able to show the existence of isotope and isobar. So that was the limitations of Dalton theory. So this is all about Dalton theory. Okay, the Dalton imaging it like atom look like a ball and nothing inside. But what happened, then we found an element, okay, like uranium. Okay, and uranium is a radioactive element, and radioactive element emit light. Okay, if the atom is undivisible, then from where this light is coming from? Okay, so that question blows the mind of scientists. Okay, it means they have something, that's why the energy is coming out of the atom. Understood? So discovery of radioactivity or radioactive elements made scientists to think more about the atom, that atom have something. Okay, and this is the definition. What is radioactivity? Better, emission of energy or particles, when particles or energy is emitting from certain atom. Okay, if they are individual, how they emit particle? Understood? So these question came in their mind, and this led them think that what the atom made up of. Okay, so atom don't show any color. Okay, now J.J. Thomson, now the next scientist discovered the atomic theory. Okay, according to J.J. Thomson atomic model, I have written something about it. J.J. Thomson, you should learn when he got the Nobel Prize. Okay, and from where he was, what was his workplace. Okay, so just go through it. So what was his experiment? His experiment was cathode ray tube. From cathode ray tube experiment, he discovered electron. Understood? It means atom has electron. And how he get to know? He get to know with this experiment. Actually, he was studying the conduction of electric current through gases at very low pressure. Okay, what he did, he created a vacuum tube. Okay, and he connect this vacuum tube with high voltage, and he put two electrodes, cathode and anode. Cathode is negative charge and this is positive charge. Okay, and can you see this is high voltage supply. Okay, and when high voltage supply is switched on, or when high voltage applied, a beam of rays was seen to travel from negative to positive. Okay, it means the beam of ray was traveling from negative to cathode to anode. Okay, and we cannot see that ray, but we can see its effect. Something was seen on the screen. Okay, then that came in mind that it means if it is getting attracted towards positive, then it might be emitting negative particles, isn't it? And these negative particle he named electron, and he also made this experiment. I think he would have put this anode here, then it was going in this direction. He would have put this electrode here, then it is going in this direction. So this is how he get to know that something negative charge particle are emitting. Okay, and they are attracted towards the positive. Okay, because negative always towards the positive, there is attraction. So, and cathode ray repelled by the, and if a second experiment he did, if he replace it with negative plate, okay, then negative charge particle cannot be attracted with negative, so it will be repelled. Okay, so that make the confirmation that negative charge particle are emitting. Okay, and he named these particles as electrons. Okay, so electron present in all the gases and different material of the cathode. Okay, because electron, all the material has cathode, isn't it? And all the material made of atom. So this is how electron present in all the atoms. Okay, and charge of electron is minus 1.6 into 10 raised to minus 19 coulomb, or you can say minus 1. Okay, and mass of electron is always less than the mass of atom. Okay, and very less, it means you can ignore the mass of the electron. This is, they are so light, understood? So that's why mass of the atom is very large as compared to the mass of electron that was present in the atom. Okay, and how he showed the electron? According to Thomson, he showed the presence of electron by plum pudding model. Okay, it means just like a watermelon. Inside watermelon, the red part is positive charge, that is continuous positive charge, and the seeds are negative charge, but the positive and negative are in equal amount. Okay, and that's why the atom is neutral, but electron can move within the sphere. Okay, so according to plum pudding model, atom is a sphere of positive charge and electrons are embedded in it and they can move, isn't it? So that was the J.J. Thomson model. Okay, and he found the electron. Okay, why it got failed? Because it could not explain Rutherford Goldfoil experiment. Okay, that we are going to study after this. Okay, he was not able to explain Rutherford Goldfoil experiment. Second, it can't explain why most of the space in an atom is empty. Can you see this red empty space? He was not able to tell why this space is empty. It could not explain stability and presence of nucleus in an atom. Okay, he was not able to explain the stability, why the atom is stable. Okay, and presence of nucleus in an atom, isn't it? That's why it got failed. Okay, what did Thomson successfully explain? So what was the success of this model? Discovery of electron was success of his model, and he told that positive and negative are equal. He proved the neutrality of the atom, and atom are divisible. Okay, that is how the electrons are were emitting. Okay, the electrons present in the atom. Okay, so we can divide. So atom is the subatomic part of the, electron is the subatomic part of the atom. Okay, now what was the Rutherford atomic model? Okay, because J.J. Thomson was not able to explain the Rutherford model. So Rutherford atomic model. Okay, Rutherford from New Zealand, and he was a student of J.J. Thomson. He got Nobel Prize in chemistry, proposed nuclear model in 1911. He discovered proton. Okay, so how he got to know? He got to know about the nucleus or proton. Okay, and what was his experiment? He worked with Ziesel and Mertson and tested Thomson model by Goldfoil experiment. Okay, he tested Thomson model. He tested this how what he did. Okay, he just set up his experiment. Okay, and what he did, can you see, this is a extremely thin gold foil. Okay, gold foil, it means it has atoms. Okay, and he bombarded positive alpha rays, okay, right on this gold foil atoms. Okay, and positive alpha ray positive charge particles. Okay, and Thomson said that in atom inside there is a continuous positive charge, and electron are just embedded in this positive charge. Okay, so when the positive rays were passing through this gold foil, okay, 3 observations he got, and then he made the conclusion from these 3 observations. So what was the observation? First observation, that most of the particle passing straight line. Okay, most of the particle passing straight line. It means he get to know that most of the nucleus, most of the atom is empty. That's why the particles are going straight line, isn't it? So first conclusion he got that most of the atom is empty. Okay, second observation, some deflected by small angle. if some are deflected by small angle, then what was the conclusion? Positive charge is concentrated in tiny center. Okay, because positive charge is here, that's why, because of positive charge they are deflected, isn't it? That's why they are deflected, because positive always repel. Okay, so that's why this positive charge inside the atom deflect the positive alpha rays. Okay, so the conclusion is positive charge is concentrated in tiny center. And the third observation, that 1 out of 12,000 uh, rays bounced completely back. Understood? So I think it is not shown here. Okay, so the rays is like rays, alpha ray was going like this, and some are reflected back. Understood? Reflected back means these are positive, and there is a that's why after positive rays, after striking with positive, there is a repulsion, so that's why they are reflecting back. So this is how he got to know that nucleus is dense, and that's why the ray is reflected back. Understood? So that was the conclusion. Okay, so this was the scattering effect. So this scattering effect shocked the Rutherford, and what he got to know? He got to know that most of the space is empty. Can you see? And positive charge is in the center of the nucleus. Okay, and electron already discovered, and electron are revolving around this nucleus. Okay, so that was the Rutherford atomic model, and he named this positive charge proton. Okay, and he named this proton is found in the nucleus. Understood? So he named nucleus, and proton is inside the nucleus. Okay, beta, and the mass of the proton is very much than the electron. It is 1836 times the electron. Okay, and according to his model, the diameter, if the diameter of atom is 10 raised to power minus 10 meter, then nucleus is very small, it's 10 raised to power minus 15 meter, only this nucleus that contain proton. Now what are the postulates or characteristics? So its characteristics of Rutherford model are: most of the space is empty in atom. Okay, from this observation he got to know nucleus is exist in center, and the most of the mass concentrated in center of the atom. Okay, because most of the rays passing straight, so that's why most of the mass in the center. Electron revolve around the nucleus, and he discovered the proton, and proton charge is opposite of electron. Okay, so charge is equal and opposite, but mass is very high of proton in comparison to electron. Okay, so it means electron is equal to proton according to Rutherford atomic model. If they are equal, only then atom is stable. Okay, so for example, if we are having helium atom, it has 2 proton, 2 electron. If we are having sodium atomic number 11, so it has 11 proton and 11 electron and 11 protons. But now what is the limitation of Rutherford model? The limitation is according to classical physics. What classical physics says? That revolving electron lose energy, and electron fall into the nucleus, because electron is a negative charge. If it is revolving about nucleus, okay, it is losing its energy, and it will fall into the nucleus, because nucleus is positive. Okay, and electron is negative, so it will fall into the nucleus. So it would not explain the stability of the nucleus, isn't it? Okay, so that's why it was not able to explain the stability of atom. But why electron not fall into the nucleus? If it is electron losing its energy, then why it is not going inside the nucleus? So he was not able to explain these facts. Okay, so that's why we need new model, because Rutherford also not able to explain the stability of atom. Okay, and Rutherford also named this its atom planetary model. Okay, you can see here. Okay, Rutherford was not able to explain stability. Okay, it means if it is revolving around it, it will lose energy and will go inside, but not able to explain. So after that, the Neil Bohr came into existence. Okay, and he just modified Rutherford model, and so we will study Bohr model. Okay, but these are pros and cons from the CPSC book, so you can go through these questions, and solutions I have written here. Now Neil Bohr's model. What was the Neil Bohr's model? He was from Denmark. He proposed his model in 1913, and Nobel Prize he got in 1922. Okay, so he explained the stability of atom. Okay, how he explained? According to the Bohr, he told that this proton is inside, the nucleus, but electrons are revolving about the nucleus in shells or in different energy levels. Okay, and he named the shells, first shell K, after that L, after that M, after that N. Okay, so these are the name of the shell, K, L, M, N. Okay, and K shell is the nearest to the nucleus. It means electron revolving, but they are revolving in a fixed orbit as per their energies. Okay, so these are the achievement that the shells and energy is same beta, shell also called the energy level. So he explained the stability of atom. So he introduced concept of fixed energy level, that electrons are revolving in fixed energy level. Okay, and he explained the absorption and emission of energy by electron and improved the Rutherford model. What is this third point? This third point said that if it will lose energy, for example in M shell electrons are there, if after losing energy it will come into the K level, and after gaining energy it will come into the N level. So they can change their energy level after absorbing or emission of energy by the electron. Understood? So this is how it explained, Neil-Bohr model. So these are the postulates, that electron move in fixed shells or fixed orbit or fixed energy levels. K, L, M, N. He named the shell. Electron do not lose energy in shell. If it is in this shell, it will not lose energy. Okay, it will constantly move in this shell only. It will not go to this, not go to this. Okay, and each shell has fixed energy. So this shell has fixed energy. Energy increases away from the nucleus. Okay, it means lowest energy, this is the lowest energy level, this is the highest energy level. Okay, that this is how the energy increasing from lowest to highest energy level. And electron can jump between the shell. How electron can jump? When energy is absorbed by the electron, because it has absorbed the energy, it has more energy, so it will jump into the higher level. But if it will release energy or it will lose energy, it will go to the lower energy level. Okay, this is how the electrons are behaving in the atom. But what was the limitations of Bohr model? Actually, it worked mainly for hydrogen atom, only one electron species. Okay, it could not explain the fine detail of atomic structure. Okay, and could not explain some behavior like magnetic and electric field behavior, Zeeman and Stark effect, that you will study in higher classes. And more improvement was needed to the model. Okay, and this led to development of quantum mechanical model. Okay, this is also you will read in higher level. Okay, so now Neil Bohr student was James Chadwick. Okay, and James Chadwick discovered the proton. Why the presence of proton discovered? Yes. No, he discovered the neutron. Okay, electron, proton are already discovered. So why the neutron discovery was important? Okay, because as per this model, okay, proton have positive charge and electron has negative. Okay, then why if there are number of proton beta, then why because positive proton are attract each other. Okay, no, positive repel, same repel now. Then why they push each other, why they are not pushing each other inside the nucleus? Okay, because proton have positive charge inside the nucleus, then why they are not pushing each other? Okay, why it is bound in the nucleus, this positive charge or proton? Why? Because neutron is also present inside the nucleus with the proton, and neutron are neutral. Okay, so what is the role of neutron? So James Chadwick discovered the neutron, and he told the role of neutron, that neutron reduce the repulsion by increasing the distance between protons. Okay, now proton inside the nucleus. Okay, so what the neutron will bind the protons inside the nucleus. Okay, so yes, so neutron reduce the repulsion by increasing the distance between proton and by strengthening the strong nuclear force which bind all the particles together. So neutron will bind the all particles, proton together inside the nucleus. Okay, and neutron play very important role, because heavier atom need more neutron to the nucleus tightly bound and stable. Okay, heavier the metal is meant more neutron inside the atom. Okay, so neutron decide the weight of the atom. Now what if atom has no empty space? This is important question. Now you can say atom has empty space here. This is positive, this is empty space. Beta, if there is no empty space, its size would be very small. isn't it? Because empty space is there, then you will be able to study the atom. Okay, if size is very small, then it will be, the object size will be greatly affected. Okay, so that's why there is a space between the atoms. Okay, what contribute to the mass of the atom? I told you the mass is all inside the nucleus. Okay, you can say 90% mass inside the nucleus and other is outside electron, and whole space is also. Okay, space is also there, empty space is also there. Okay, so inside the nucleus there is proton and neutron, and that constitute the maximum mass of the atom. Okay, so proton and neutron or nucleus, that form a nucleus, contribute to the mass of the atom. Okay, for example, hydrogen has 1 proton and mass is 1 unit. Helium has 2 proton but mass is 4 unit. Okay, why this is 4 times of hydrogen? Because it is extra neutron. Okay, so neutron contribute to the mass of the atom. So it has extra neutron, which helium has extra neutron. Okay, now electron, proton, neutron are discovered, and there are 3 subatomic particles of atom. Okay, now few examples are there. For example, carbon has 6 protons, 6 neutron. Proton and neutron should be equal in an atom. Okay, and iron has 26 proton but 30 neutron. Now proton and neutron are not equal. Okay, why? Because proton, neutron are more here. I can say proton and electron should be equal. Okay, but here neutron are more. Okay, so that's why neutron are more here. Now oxygen 8 proton, 8 neutron. In uranium 92 proton and 146 neutron. Okay, because iron is heavy. Okay, so mass is because of the neutron. Okay, and electrons are equal to the proton in an atom. How much the proton? The electron will be same, but neutron can vary because neutron are responsible for the mass. Okay, and they hold the nucleus tightly and stable. So these are the pose and pointer from 8 to 16. Okay, and after that, contribution of neutron scattering experiment during Dhruv Research Center. Okay, so in India there is a Dhruva Research Center, and they are asking what is the contribution of neutron scattering experiment. Okay, so a neutron scattering experiment help in understanding material like superconductor, better electrode, drug molecule, alloy, and better medicine. Okay, so remember this question. Now comes to the second half of the chapter, and this is symbols of elements. Okay, you might have seen the periodic table, and in periodic table each element has their own symbol. Okay, and how the symbol were given to the elements? Okay, first Dalton gave symbol to the elements. He gave the pictorial symbol to the element. Hydrogen will look like this, carbon will look like this, oxygen is look like this, and so on. But it's very hard to remember all the pictures of the periodic table because there are so many elements in the periodic table. Okay, but later IUPAC name were given. Okay, IUPAC names were driven from the Latin name of the element, and its full form is International Union of Pure and Applied Chemistry. Okay, and he introduced alphabetical symbol in 1813. So IUPAC name approves name and symbols. So according to them, the first letter of the element should be capital. If second letter and first letter, if there are 2 elements having same letter, first letter, then you can choose the second letter but with small letter. Okay, for example, beryllium and boron both are starting with B. So to avoid the confusion, beryllium we include BE small letter and boron B. Okay, this is how just they name they give the symbol to the elements. Okay, so these are the rule of the IUPAC symbol. Just read it. Okay, and there is a comparison I have created for all the models: Dalton, J.J. Thomson, Rutherford, and Bohr. Okay, so go through this because I have taught you everything about this. Okay. Yes, again the electron, proton, neutron discovered. Okay, charge is -1 for electron, +1 this, and neutron are neutral. They are neutral charge. Neutral doesn't mean that they are zero charge. Okay, there is nothing in the world which has zero charge. Neutral means they have equal positive and equal negative. So that wise it's got neutralized. Okay, and its electron mass is negligible. and it has 1 unit mass, it has 1 unit mass. And we know according electron revolve outside the nucleus, and they both are inside the nucleus, proton and neutron. So proton and neutron inside nucleus, and electron revolving outside the nucleus in their shells, orbits, or energy levels. Okay, now let's decode the atomic number and atomic mass. So these are the symbols given to the elements. Okay, this is how they are representing with the symbols. So atomic number we represent with Z, and atomic mass we represent with A. So atomic number determine element identity. Okay, by seeing the atomic number you can identify which is the element. For example, helium atomic number is 2. Okay, so it is at second number, so it is helium. So sodium has atomic number 11, so it is sodium. So this is how atomic number give identity. And atomic number is equal to the number of proton and number of electron. Okay, now what is the mass number? Mass number of an atom is the sum of proton and neutron. Proton and neutron are inside the nucleus. Okay, so they combined give the maximum mass of the atom. So this is the mass number. Okay, now the very important question, why electrons are ignored when we consider the mass number? Okay, because electron have very less mass. I told you na that electron mass is 1836 times less than the proton. Okay, so this is how we can ignore the mass of the electron. So that's why mass number only include proton and neutron, not electron. Okay, this is an example. Can you see hydrogen? This is atomic number. This is how we represent. Okay, this is a atom or element. This is atomic number. This is atomic mass. Okay, so this is hydrogen, atomic number is 1, and I told you atomic number gives you the proton and neutron. So you know one proton, proton, yeah, and electron. So one electron and one proton, and this 2 is atomic mass. Okay, and atomic mass is sum of proton and neutron. So proton and neutron, 1 plus 1 is 2. Okay, so atomic number is equal to number of electron and number of proton, that is 1, but atomic mass is proton and neutron both are 1 1, so it makes 2. So why not, I told you this, that why we not including electron while calculating mass, because electron mass is negligible, that's why we ignore it. So these are the examples of 3 elements that gives you how to find the proton, neutron and atomic mass. Okay, because helium has 2 proton and 2 neutrons, so 2 plus 2 makes 4, so atomic mass is 4. And lithium has 3 proton and 3 neutron, 3 plus 4 7, so atomic mass is 7. And atomic number is equal to the number of protons, so atomic number and electrons are 3. Now atomic numbers tells us what the element is, and mass number tells how heavy the nucleus is. Okay, this is the notation of an atom I told you. Now this is an example. An atom has atomic number 9 and mass number 19. Find the proton, electron and neutron. Okay, atomic number 9. Atomic number means number of proton or number of electron, that is 9. And if we want to find the neutron, how we will find? We can subtract from atomic mass number minus atomic number will give you the neutron. So 19 minus 9 will give you the neutron 10. Okay, and this is how the neutron plus proton is 19, it will give you the mass number, and that is 19, 10 plus 9. Okay, now electron distribution in energy level, how the electron distributed, okay, in an atom. Okay, as I told you that electron are distributed in the shells. Okay, but how they are distributed in the shells? K, L, M, N. Okay, in first shell, number 1 shell, this is the formula, and it makes 2. So in first shell only 2 electron will come. Okay, and in second shell 8 electron will come. Second shell, this one now, 8 electron. In third shell 18 electron will come. Okay, we put 1 2 3 at place of n, and this is how we can calculate the number of maximum electron in shells. Okay, and this is the rule for filling this electron. Okay, first we have to fill the first shell with 2. Okay, after that we have to completely fill the second shell with 8, and this is, and so on. inner shell should be filled first with 2 outer electron known as valence electron, and the last shell we name is the valence shell, and the electron in the last shell we call the valence electrons. Okay, and this is the table that is showing everything, KLM, and how these are filled. Okay, for example, we will take sodium here. Sodium atomic number 11. Okay, atomic number 11. So in first shell there will be 2 electron, in second 8. So 11, 1 is left. So valence electron is 1 here. Okay, so this is how this is valence electron in M shell. Okay, this is valence shell for this. So you can calculate for all. For example, oxygen atomic number 6. So first shell 2 and second shell 6 will come. Okay, now valency or combining capacity. Okay, what is valency? Valency is the combining capacity of element or atom. Okay, so the valence shell are responsible for the combining capacity of an atom. Okay, for example, again sodium has 1 electron in valence shell, and oxygen has 2 electron in valence shell, and every atom wants to become stable. To become stable, he wants to complete their octet. Octet means everyone wants 8 electron in outermost shell or in valence shell. Okay, so he also want 8. So what he will do? He can't take 7. So sodium will prefer to give 1. So it will release 1 and become positive cation. So it will become sodium positive, sodium cation. Okay, and this is 6. So it also want to become 8. So because it will be easy for it to take 2. Okay, instead giving 6. He don't want to give more, so he want to take less. So it will take 2, and by taking 2 it will become oxygen 2 negative, that is anion. Okay, and this is how they combine, by giving or taking from others. So they make friendship with other elements. Okay, so these are the rules. So outermost shell is called valence shell. I told you electron in valence are valence electron. Atom with incomplete valence shell are more reactive. It is incomplete, they are more reactive. So they want to react with other and they form compound because they want to complete the octet. Okay, and this is the rule for the valency of an atom. If valence electron is less than 4, it gives to other, or it will lose. Okay, and it will give the atom to other and combine with them. Okay, make friendship with them, you can say. And if valence electron are 4 is called half filled shell. If it is half filled shell, it will neither give neither take from other. Okay, it just can share. If it is more than 4, 5, 6, 7, so what it will wish to take 3, 2 or 1 to complete its octet. Okay, and form the compound. Okay, if atom has already 8 electron in valence shell, for example stable neon. Okay, neon has 8 in valence shell. So what he will do? It will neither take neither give. They are already stable. Okay, and these are the stable neon, argon and krypton. And how role of the valency is, because valence electron atom combine with other atom and they form compound. For example, sodium has electronic configuration 281. Okay, so it will give 1 to chlorine. Okay, chlorine has 287, so it will take 1 from sodium. Okay, so this is how they will add and they will form Na plus Cl negative. Okay, Na plus Cl negative, sodium chloride compound is formed. Okay, so this is the role of the valency, that they form compound. Water, carbon dioxide, they all are compound. Okay, now what are isotopes and isobars? Okay, what are isotopes? Iso means same. Okay, it means same elements but different atomic mass. Okay, simply you can say that in nature few elements found with their twins. Okay, a few elements twins also found in nature, we can say in simple way. So isotopes are twins atom of same element that found in nature but different atomic mass. For example, hydrogen is found with their twins. For example, hydrogen found as protium, deuterium and tritium. Their electron or proton is same. It means mass atomic number is same but mass number is different. Why? Because neutrons are different. Okay, it has 0 neutron, it has 1 neutron, it has 2 neutrons. So neutron decide the mass of the atom. So it is the, you can say it is heavier. Okay, it is less heavier and it is the lightest because it has 2 neutrons, so this is the heaviest. Okay, so protium found maximum abundance in nature. Okay, this is the mostly found in nature. Similarly, isotopes of carbon also found. Okay, these are the these are the notations of atoms. Okay, carbon 12, carbon 13 and carbon 14. Now you can see only neutron is 6 here, neutron is 7, neutron is 8. Okay, so neutron are different and they are the twins of the isotopes. Okay, why do yes, carbon, this is the most abundant in nature. Now the question, why different physical properties of isotopes and atom? See, isotopes have different physical property but similar chemical properties. Okay, why different physical property? Because their masses are different. Can you see mass is different? Okay, its mass is 1, its mass is 2, its mass is 3. So mass is different. Okay, because why mass is different? Because neutrons are different, so their density, melting point, boiling point will be different. Therefore physical properties are different, but similar chemical properties are similar because all the 3 isotopes have same number of electrons. Electrons are same in the valence shell, isn't it? Okay, so that's why they similarly will chemically react with the other. Okay, because reactivity depend upon the valency. Okay, and valence electron decided by the atomic number, and atomic number is same, only atomic mass is different, no? So they are having same atomic number but different atomic mass. All isotopes of an atom have same chemical but different physical properties that I told you. Now unit of atomic mass, as the weight, time, distance measured in kilogram, meter, second, and the similar the atomic mass measured in unified atomic mass unit. Okay, so isotopes are nothing but same atomic number, it means proton and electron, but different atomic mass, different neutrons. Okay, that is average atomic mass unit. Okay, this is very important regarding the numericals. What it is told that the isotopes found in different amount in nature. Okay, for example, the isotopes of chlorine 35 and chlorine 37. Chlorine found 75% in nature and chlorine 37 found 25% in nature. So their ratio is 3:1. Okay, this is how they are found in nature. Okay, so how we can find the average weight? So average weight is found with this formula. Mass of the chlorine atom, that is 35, into percentage fraction. It means 75%, 75 upon 100. And plus mass of the other isotope, that is 13, into percentage, 25 upon 100. So this is 35 upon 5. Their average weight we can calculate of the isotopes. Okay, so this is why we see fractional masses like 35.5 unit. Okay, this is the natural average of the isotope, and we see that chlorine 35 is more abundant, so average mass will closer to 35 than this 37, isn't it? Okay, for example, if we are having 1 million chlorine atom, 1 million, then 75% will be chlorine 35 and 25% will be of 37. So that will make the ratio of 3:1. These are the applications of isotopes, how they are used in energy formation, in medicine, in archaeology, okay, and in nuclear reactors they are also useful. Now this is the pose and ponder of 17th, 8th, 18th question. Now the last topic, let's meet the isobar. Isobar means, can you see we are having different elements, argon, krypton and calcium. Okay, they are having same atomic mass but their atomic number is different, 18, 19, 20. So these are called isobars. It means different proton but total mass is exactly 40. Atomic mass is same but atomic number is different. They are called isobars. So there is a comparison between isobar and isotope. Just go through it. It will increase your knowledge, your understanding. And the last one, how the scientists see the atom. We know that we cannot see the atoms with the naked eye, so we use special kind of microscope. First is STM, scanning tunneling microscope. Okay, it will study the surface of the atom. And the second is transmission electron microscope. It will study the internal arrangement of the atom. So our chapter is over. Okay, yeah, last. So Bohr model. was the last model that we have studied in this chapter. Okay, but after that we have modern atomic model, okay, that you will study in next classes. Okay, so in Bohr model, electrons revolve around the nucleus in shells. Okay, and this is also not entirely correct. Okay, but because electrons are not following this path, fixed path in the orbit. Okay, as per the modern atomic theory, electrons exist as electron cloud. Can you see electron cloud? It means their position is not fixed in the orbit. So this theory also not exact. Okay, so and more theory will come. Okay, as the scientists will just keep researching. So this is our chapter that is finished. Now these are the solutions of our NCERT questions. Okay, so take a screenshot of these solutions and learn all the questions, because chapter is clear, so easily you can solve all the numericals. Okay, so let's wind up the chapter. Hope you like this chapter. Okay, and this is the worksheet. You can also go through it. Okay, solve this worksheet. It will be very helpful. If you have done the chapter, you will be able to solve this worksheet. Okay, so let's stop this chapter. This